Good morning, maybe good evening to some or good afternoon to some. My name is Jerry Klanac, and I'm going to be presenting a topic called Bringing GPM and NetRisk into the Graduate Classroom. What this is going to be is experiences that I've had over the last several months in teaching a brand new course at the University of Dayton related to risk management for construction projects. My presentation is in 4 parts. First of all, we'll go over the background of the course and me as the instructor, and then drill down to the teaching approach that was used for schedule risk analysis, which is a component of the course. Talk about the case study assignment is where we were using both NetPoint and NetRisk as tools for the students to prepare a schedule model and then bring the schedule model into a simulation tool. And then lastly, talk about something interesting that was almost an add-on to the course about calibration in terms of inputs to cost and schedule risk analysis models and some things I learned in that exercise that I did with the students. Many of you know that I work with PMA and still work for PMA. I've been with PMA since 1989, and I'm now in a part-time mode with PMA because I'm a full-time faculty member at the University of Dayton. I did a transition 2 years ago to be the director of an upcoming master's program in construction engineering and management. The actual program is a little stalled, mostly because of the pandemic and other factors, but we have launched the curriculum and I've been pretty active in developing new courses. From a standpoint of risk analysis, I've been doing risk analysis for almost 25 years now, and it's really great to be able to take my experiences and learnings from all the projects I've done around the world and bring them into the classroom for the students to kind of absorb all the knowledge I have on risk management and use of simulation tools, et cetera, as part of the quantitative risk analysis perspective. From a standpoint of just background, the types of projects that I've been able over the years to be fortunate to be involved with to do schedule risk analysis is quite broad. A lot of focus in what I call process plant type projects in the oil and gas industry. And in some regards, the pharma and life sciences projects have a lot of process plant components to it, although there is some built environment perspectives to it. Because of one of the client's interest in alternative energy and a whole host of other projects I've been able to be connected with. In addition, there's a host of hodgepodge of different types of projects, some in the built environment world, others in various different capacities. In terms of these projects, it's not only schedule risk analysis that we did. Sometimes we were facilitating the identification of risk. Sometimes we're helping them do qualitative risk analysis, and we're also doing cost risk analysis. The beauty of my experience is I've seen projects all around the world, and that's quite interesting for me able to take some of these experiences and bring them into the classroom. Given the background at the University of Dayton, a lot of the graduate students are international in nature, and so having an instructor that has a lot of international experience is very attractive for them, and they reach out to me a lot just to find out what I've learned over the years in getting engaged in these projects, and it really helps them prepare themselves for their life after graduate school. Next slide gets in a little bit of background of our program and kind of put in a context where the schedule, or excuse me, the risk management course was. This is the proposal we developed about 2.5 years ago for the University of Dayton. I'm not about to go through all the details here. The boxes in red would be the core courses that we were seeking all graduate students to take. And so it was background in construction engineering, project management, managing construction, and then there was a capstone project. We wanted to have a host of electives for students to have kind of carve their graduate experience into the areas they really wanted to concentrate on in terms of maybe more in construction management as opposed to some of the engineering technology items and data analysis that's going on. At the bottom of the flow chart here, you'll see a box that's dashed in an orange line. This is what I call CEM 523. That's going to be the number of the course when we actually go into a CEM mode when the actual program is in place. Right now, all the courses are under the umbrella of a construction engineering curriculum with a concentration in construction engineering management. That's the transition we currently are under. So this is an elective a course in the scheme of our proposed curriculum. And we basically launched a brand new course starting in January of this year. In terms of the class we had this year, I was quite surprised that we actually had 23 students in the course. There's a high interest in the courses that I teach. One of the challenges of delivering a brand new course, as well as teaching other courses, is just-in-time development of all the lectures and materials that goes into the course. In terms of the background of the students in the class, it's roughly 50% undergraduates and 50% graduate students. A lot of the undergraduates seek out construction-related courses as their technical electives in their undergraduate studies, and so this is one of those courses that would qualify. What was nice is most of the students in the class were, I call them repeat customers. They were students that had taken my courses previously, and they enjoyed the way I teach and really had some interest in risk analysis. The picture that you see here was taken last fall, and many of the students that were in the class were in this picture. It's a bridge project that was in Dayton, Ohio, that we did a field trip. We take a stand back and talk about the course itself before I drill down and talk about schedule risk analysis. There were really 4 areas that we had course objectives to, and they kind of align with the overall thinking on risk management that you would see in most textbooks or other media that relates to management or risks. We wanted to get them founded in the risk management process so they can understand how they can apply the process to any construction project. Then we went to the qualitative risk analysis, where we wanted the students to be comfortable to have the techniques to be able to identify various risks to a construction project and understand the 3 perspectives that they need to think of in terms of past experience, what they know now, what the future can be. Then have the capability to try to prioritize the risks in whatever manner makes sense. And then use a risk register as kind of the hub for all the information over the life of the project. You'll see in the next slide is that a lot of the time in the course was spent on going through quantitative risk analysis. So we wanted to train the students on being able to assemble a cost model and a schedule model, and then being able to do a Monte Carlo simulation of these models, simulating the effect of the risks to them. And then one is to do all that work, and the other is be able to interpret the results to make sense of it to whatever the end client is in terms of the analysis that you're doing. Lastly, once you kind of got this flavor of risk and how they may play into the project, go through the various strategies and tactics you may think about in terms of treating the risks. And so we spent a lot of time at the end of the term going through risk treatments and risk responses. Speaking of time, this is the overall course timetable that was done this past term. You can see there was, in essence, broken down into 3 parts. The first part covered the risk planning, the risk management process, the background on qualitative risk analysis. And in part 1, we used 2 case studies. One was the Denver International Airport to talk about really the effect of risks that could happen on a project, as well as what happens when you don't do effective risk management during the life of the project. That was really the kind of learnings in case study number 2. Case study number 1. Case study number 2 is an interesting project that is at the later stages of its development. It's a project where they're trying to link the Kentucky part and the Indiana parts of Interstate Highway I-69 with a new Ohio River bridge crossing. And so we were able to get background information off that project from the internet and apply that as a case study for the students, basically to identify risks and then use a risk register to start the initiation of tracking the risks over the life of the project. Part two, which you can tell from the graphic here, was almost like 40 to 50% of the course time, was the quantitative risk analysis. And we classically went through the cost risk analysis and then schedule risk analysis, although in many cases you do schedule risk analysis first, then you do cost risk analysis, but we kind of did it in backwards. In this particular endeavor, we used one project as the focus in the case study. It was a project that I was involved with in the early part of the 2010 decade, where a client, BP, was building a data center in their campus in Northwest Houston. So I had a lot of background information on the project that is available on the internet, so there wasn't anything very secret I could use a client project for. But then, since I was involved in doing the reviews, both from a cost risk analysis, schedule risk analysis, I at least had the structure of what the likely costs would be, as well as the schedule itself. So that was the focus of the case study. And lastly, part three, which was the last 2 or 3 weeks of the term, we got into risk treatments, and we also covered calibration concepts as part of part three. And in that case study, we used the Allegiant Stadium. This is the new Las Vegas Raiders Stadium as the case study, and really was more of identifying certain risks and then doing the risk treatments, perspectives of those risks over the life of that particular project. Getting into the actual teaching approach for schedule risk analysis, when I kind of was thinking about how I was going to create it, I certainly was trying to keep in mind what kind of case study would I be using to have the students get hands-on experience in schedule modeling as well as the risk analysis. And so one of the thoughts we had to do was, what's the topic that made sense? And we really didn't want to overwhelm the students with a big model, but something had enough material in it so they can get the flavor of doing something hands-on. One of the things in this whole thing is what kind of software you're going to use for the simulation. And after a bunch of research I did and what was available, what was effective for the students, we selected using NetRisk as a simulation tool. And then we decided to use NetPoint as the platform to build the schedule model, and then upload it into NetRisk to run the simulation. And what was really nice, obviously I've got a link within PMA that we were able to have the students get access to trial versions of both NetPoint and NetRisk, so they can actually use the tool as if they had it, in the real world. And my experience with students is they love new software. They like to figure it out. And we'll talk about the feedback they've got, but they really enjoyed the challenge of seeing something new and something that they can be used perhaps when they graduate. From a standpoint of the approach and trying to teach students how to do schedule risk analysis, a lot of the background of how I structured the class was leveraging the experiences I've had with PMA. Years ago, we created a process of how to do schedule risk analysis as early as like 2002. It has been refined. The current version is in this flow chart here. The items in box with a purple box really is the types of process steps that the students would have hands-on experience in doing the case study. So in essence, they're going to build a model, and then they're going to have to get inputs for the ranges and other things into the model, run the simulation, and then once the simulation is completed, prepare a report that would in essence be used or given to a client to give them the indication of what the schedule risk analysis would say. Okay. One of the challenges I had in thinking about how were we going to do the hands-on case study work is, what level of modeling do we really want to do? And given some work we've done internally with PMA and trying to write a better protocol to do schedule risk analysis, one of the things that we realized there are many ways that one develops a schedule model. The top box here talks about you can actually use the schedule as is. And that works really well when the schedule is got a small number of activities. It's pretty focused, especially if a project is really in the early stages of inception. and you really only have a very high level schedule to begin with. You can actually use schedules with thousands and thousands of activities, although getting the range inputs is a lot of work. And so it's pick and choose whether you want to go to the full schedule. Another very common approach is using a full schedule, but going to a lower level of depiction. I use the term level 2, meaning something that it has a very good breadth of scope definition in the schedule, but the actual durations there are more kind of month by month control of the project as opposed to week by week control that you would get at level 3. Okay. The approach that I learned many years ago when I first started doing schedule risk analysis is what I've called the sensible subset, which is that you're going to use a pretty elaborate schedule and then extract certain sequences out of the schedule that really probably are more material in terms of the outcome. What are those types of sequences? They obviously would be the critical path. You have to have some sort of perspective of what you're going to call near critical path, but extract those near critical path sequences. And lastly, given the understanding of what risk come into play, is do what we've termed as risk sensitive sequences, so that you can actually populate the model with something that perhaps has a lot of float, but then when a risk occurs, you're going to lose that float and it may become critical. And we want to simulate those perspectives. So over the years of doing risk analysis around the world in different industries, the sensible subset approach has been my kind of go-to perspective. And so one of the thoughts I had is to kind of transfer that knowledge into the students as part of the exercise. So that was the basis of the case study work that we were using for our particular class. In terms of the case study assignment, I'll give you some background information on the project itself. This is BP's High Performance Computing Center. It's in Houston, Texas. It's a 110,000 square foot building with 3 stories. That picture is actually the final product. It's been in service since 2013. We conducted risk reviews in 2011 and 2012 towards the kind of the end of the development of construction documents in terms of the timing of the particular review. And then we actually did a review halfway through construction as well. Okay. In terms of what I used for the case study, I did modify the actual performance data that was there, just so the confidentiality of the project was maintained. Okay. From a standpoint of what the students had to work with, is I typically write up a case study narrative. They actually get quite long. Students sometimes gripe about that. You write too long of a case study, and I tell them I'm trying to teach them a skill of what's important in documents versus which is not important in terms of what you're trying to get out of it. That's a skill that I learned when I got my MBA. So they basically had a narrative to explain the project, but it's beyond just the project background. We actually had to give them schedule information. Students do not have access to Primavera, so I could not give them a Primavera schedule file. So I had to give them bar chart outputs of the Primavera schedule that was modified for the this exercise. So they actually had a bar chart of the entire remaining work. One thing to note, this particular exercise was done where probably 30% of construction was already completed. So building up many parts of the structure of this building was already activities completed. What we were trying to simulate was the behavior of the remaining work. Okay. So they had a bar chart based upon the work breakdown structure, and then a bar chart that sorted those same activities by total float, early start, and early finish. When we do risk analysis, quite often when we have, especially have a large schedule, this is one of the sorts we commonly use to try to identify what's the critical path, what are the near critical paths, et cetera, to help us create the schedule model. So that was the technique I was trying to share with the students and have them go through. In addition to the schedule basis information, they basically had part of the narrative, like a summary of interviews that would have been conducted with project participants that dealt with what would be the ranges for the different uncertainty underlying many of the activities in the schedule, and then how to deal with 2 discrete risk events that were occurring over the remainder of the job. So in essence, in terms of preparing the model, they can deal with the overall input of ranges on durations, as well as the individual risks being applied to various activities. From the standpoint of what the students had to do, these were the kind of the 5 steps that were involved. They had to take all the schedule information that was given to them and prepare a schedule model. And that model was going to be built in the NetPoint platform. And then once the schedule model was complete, then they would upload that model into NetRisk. Okay. And then once all the schedule information is NetRisk, they had to enter the ranges and risks into the model in the NetRisk platform. And then when everything was stable, they had to do, in essence, 2 sets of simulations. The first simulation was what I call a base run, which assumes no use of float and in essence gets the earliest possible timing of the simulated outcome. And then there was a float use sensitivity where 50% of the float use was considered. So in essence, they can see perhaps the early curve and late curve difference in the outcome of the scheduled risk analysis. Once they have successfully run the simulations, the last part of their case study work was to interpret the results as part of their case study work. In terms of the schedule model that they would have to prepare at a high level, this is the details of the schedule model. One of the things about this model is that we basically limited the float values of activities to be less than 4 weeks of float or 20 days. So it kept the model down to a manageable number of activities. Okay. One of the things that I found when I had the students do this, they were very successful at taking schedule information and building the NetPoint model. What they struggled with was trying to interpret the schedule information they got and be able to develop the sequences. So that was something that was learned and is kind of something I'll talk about a little bit later on kind of learnings or improvements for the next time I deliver the course. But the bottom line is ultimately I gave them my version of the model for them to compare their version so they can learn what was missing from their version, or what was a gap in theirs versus what was, kind of deemed to be the instructor solution. The reason I did that is because I wanted their experience in the simulation tool to go well, to have a well-structured model, so they actually could, get to a right level of performance. Okay. From the standpoint of using NetRisk to do the simulation, the 3 kind of features that we really wanted them to get hands-on experience on was being able to do the range inputs on the activity durations. And so there was actually some of the range inputs they had to think through, what values they're going to put into. That wasn't exactly given to them, which was part of the challenge of the exercise. Then in inputting the 2 discrete risk events, one risk event dealt with the possible delay of a utility company doing their scope of work. And the other discrete risk event was during the commissioning of the air conditioning units, that there would be some sort of failure in that particular testing, and then they would have to take more time to do that particular work. And lastly, because of the ability of NetRisk to simulate the use of float, that we wanted to go through that process of using that feature and functionality in NetRisk to be able to have that alternate perspective of the outcome of the simulation. From a standpoint of, what would be the results that the students would prepare, this would be the classic probability distribution output. The end part of the network was a milestone saying ready for move in, meaning that all the construction work is done, all the commissioning work is done, it passed through the city inspection, and they're able to now move equipment as well as staff into the building. Okay. So this is the outcome of this. And I would say all the students were able to generate this. Given what they decided on the ranges, there would be some variability in the kind of the timing of what their curve is, but it was good to see that all 23 students actually prepared this type of output. One of the other outputs that they were requested to do was prepare a tornado diagram, in essence, help to interpret the simulation results. And we use the duration cruciality as one of the perspectives to look at in terms of the statistical outputs from the simulation. And why I choose this is typically the duration cruciality is a good indication of which of the risks or which of the activities has the most influence in the simulation model. And as I kind of share with the students, is if you're trying to adjust the schedule in some manner, you'll use this rank order of information on this graphic to start looking at individual risk, individual activities as candidates for improvement. When you're an instructor, you have to grade assignments. I typically use some sort of scorecard or rubric. And so this is an example of the rubric that I use for this particular case study exercise. Question 1 was all about development of the schedule model. And so, the evaluation I tried to do was the content of the model in terms of, is all the right types of activities in it? Is it logically linked or not? And what I found with the students is they were very good at putting the logic in. And then the timing. Did the timing of the model could be consistent with the schedule information that was provided? And so that was the first part. And basically, I think the overall score there adds up to 35 out of the possible 100 points on this particular case study assignment. Part 2 was all about the simulation and using NetRisk. And so, as I mentioned, there's really 2 simulation runs to be done: a base run without the use of float, and then a second run with the use of float. So they were graded on, how well did they put the range information in. What was really nice is many of the students gave me their NetRisk file. So I was able to see exactly what they were and compare it against the solution I had, and then provide them very detailed feedback. If their answers weren't very consistent with mine, then I can actually say, well, this is why. And students really like it when you can give them very specific feedback. So you look at your range inputs, you look at how they describe discrete risks, and there's a set of information you need to put in about the risk itself, as well as being able to assign it to an individual sets of activities where the risk may be come into play. And lastly, do the simulation results make sense in terms of reports of the probability distribution and the development of the tornado diagrams? Kind of part B of the second question was doing the second simulation, recognizing the use of float concept. And so it's similar to the first review, but it's only looking at how well did they actually do the inputs to turn on the floating considerations within NetRisk and then running the simulation. Okay. And lastly, and it's funny how some students forget to do the very end, is given all the information, what's your recommendation on when the project will be finished? And so that the last part of that is there. How did the students perform? This is a distribution of the grades on this particular exercise. What was nice is, 74% of the students basically had 90 or above. Why you see kind of groupings together is a lot of students do work together, and they will make the same mistakes when they do that. But overall, I think it was, a very good effort on their part that they got through all this work. It took a little longer than we expected, but they fought through it given other constraints they have on their time, but they did enjoy it. We'll get into some comments in a few minutes from them. In terms of what did we find as kind of the common faults or errors that the students had, some of the students, especially the ones that you see kind of below 86 or so, they failed to put all the range information in. I think they probably went certain far and then they just stopped for whatever reason. So obviously when you don't put range information, you're not going to get any variability on those activities. So That was one of the flaws that I commonly saw. I found students were very good at putting the discrete risk events into NetRisk. However, they would have some sort of problem in putting the actual impact values in. They must have misunderstood what information they were given and how they applied into NetRisk. So there was a number of students that failed to do that. There was a few students that failed to actually do part B of question number 2, which was to do the simulation considering float use. And so that was a problem. And lastly, as I mentioned before, some failed to actually make a recommendation. So that's why they're scored there. As an instructor, I was quite pleased of the outcome of this. I did have to grant a little bit more time and extensions to do the assignment, but I thought it was really valuable that they actually got through it completely as opposed to having an arbitration completion date. So if I step back and say, was this a valuable exercise in terms of the case study? And I kind of going through in my mind the positive and negatives. I'll start with the positive, obviously, first. Students are sponges, and they really adapt well when there's something new and something they want to learn. So getting their hands on NetPoint and NetRisk was really, really, really good. I found that students had very little questions about understanding each tool. They were more, when they kind of approached me, whether it was before class or in office hours, was, do I have the right answer? That's kind of where they were more concerned about, as opposed to really understanding the tool, okay? As I mentioned before, 74% of the students scored 90% or higher. What was interesting is one of the questions on the final exam related to GPM and NetPoint principles. And of the 18 students that got that question, because the questions are randomly generated, all 18 got the questions right, which was nice to see. From a negative standpoint, the students struggle a little bit with the sensible subset approach to building a model. And that's mostly due to the level of experience in scheduling. It's actually it's an advanced concept, is probably the best way to say it. And so that was a little hard for them as I look back. In some regards, the schedule information that I gave them was a little bit flawed. And I think it would be better if I had something with a bit more construction work, as opposed to something that most of the critical work went through commissioning as opposed to construction work. So one of my takeaways is to look at the basis of the schedule I'm going to use for this particular project when I teach this next time. As I mentioned earlier, the assignment took a lot longer than what I initially expected, but I'm one that wants students to learn. So I'm quite gracious in giving them time extensions. And so, like I say, all 23 students did submit their work, but it took probably twice as long that I expected. Now, part of the length is because we had a couple of breaks in the term that kind of stalls things out a little bit. If I back up and say, what's the verdict on this? I thought, yes, the exercise was very valuable to them. I would continue to use NetPoint and NetRisk for this assignment. It worked out very well from using the trial versions. The students really got up the learning curve very quickly and performed very well. The only takeaway is really look at the information I'm giving them in this case study and see if I can upgrade this. Now, this is late breaking news. The student feedback for the course was released like 9 o'clock this morning. So I scrambled together to put this slide, but I think it's nice to share the real perspective from the student. In the box on the right is the overall kind of the key metric in the student feedback. The question is, would you recommend this course to others? And perfection is 5.0, and this course got 4.8. And most of my courses are in the 4.8 range, so it's consistent with that. So in essence, it in terms of performance of the course, it's consistent with others that I've delivered at the University of Dayton. I'm going to read off these 4 comments that I was able to extract this morning. One of the questions was, what was the most effective thing in helping you to learn in the course? And a student basically said NetPoint, NetRisk. So it's obviously a student that really enjoys learning new software, has a passion for construction engineering and management, and may even have a career in doing risk analysis. From a standpoint of the case studies, this is a very common feedback I get. The case studies really applied to what we were learning and introduced us to many stimulating projects. I typically like to write case studies that have a theme of something they can learn beyond just the material that's covered in class, so it kind of puts things in perspectives in the real world. Other comment was classes devoted to going through the software and the explanation of the outputs were very helpful in understanding the material. And I think that's really important as it relates to when you're teaching GPM and NetPoint for schedule development, and then NetRisk for schedule simulation, is what is it you're going to get out and how do you use it? And I spent a lot of time on that in several lectures. Lastly, the last comment, awesome class. I really did not know much about risk analysis, but I am interested in my future career to explore it. I think I know who the student is, and I had talked to him actually in the winter and told him about the class, and he was really interested in it. And I think he could actually be a good risk analyst down the road if he pursues it. Okay. The last part of this session talks about calibration exercise. And I have to thank a colleague at PMA, Francisco Cruz, who tipped me off on this particular topic. He has a passion for it. And I think some of his passion is rubbing off on me a bit. And what this is all about is we're trying, when we do risk analysis, whether it's cost risk analysis or schedule risk analysis, we actually interact with project participants. And we really rely on their input to do a good analysis. But we really want realistic input, sensible input, things that are calibrated for what's reality. Okay. So there's kind of the perspective of trying to identify who can you count on when you interact with various project participants to give you some realistic input as you're considering what you need to as inputs in your simulation models. Okay. So what I did in the class, and this is built on some work that is out there, is gone through some sort of calibration testing type exercise, where basically I conduct a first quiz, which asks students to develop a 90% confidence interval for a series of trivia related questions. In other words, here's a question, tell me your boundaries on what's kind of the P10 level, what's your P90 level, and some value in between is the most likely. Okay. So that would be a series of 15 questions. And then second part is a series of another 15 questions that are all true and false, and you have to respond to it, but you also have to provide their level of confidence in the response. And we'll show you an example of these in a minute. Then basically, once I took one class where we did the quizzes, I had a day in between the class on Monday, then a class on Wednesday. Then I was able to take the data from the quizzes and interpret for them and basically share with the students a level of calibration they had in setting ranges, and then what's their level of confidence in kind of providing responses kind of in the binary perspective of a true and false. To give you an example of what the questions are like, here's an example question. In developed countries, what is the average daily calorie intake per person? And so the possible response that we're trying to get from the various students is, what's your most likely value? So you may specify it as 2,700 calories. Pessimistic is 4,000. The optimistic is 1,800. And guess what that is? And so there would be a series of 15 questions like this. What we did is then looked at their performance in there. And what you see, these are out of the 20 or so students that did this particular quiz, not all 23 students were in the class that day, is given the type of questions, how many actually got the ranges, correct for the actual result. And you can see the results. There's a lot more blue here than orange, meaning the orange is that they were successful in defining the range, and in many cases they were not. Okay. It's interesting, questions like the composition of bronze and the population of Miami, Florida, they didn't have any correct answers. One of the ones that struck me a little interesting is only one student got this right, is what's the length of the Channel Tunnel that connects the UK to France? And I know just from living in UK, it's like 30 miles. And I had a lot of ranges that were thousands of miles. So it's obviously, a little difficult on some of these trivia items. What you can do, though, is once you have a population that you do these quiz for, you can compare against what would be the standard performance and then a performance of an audience that is perfectly calibrated. So you've got different colored bars on this chart. The one in the blues is kind of the standard distribution for those that are, some could be more calibrated than others. The ones in the orange are those that go through some sort of calibration training, and they become much more highly calibrated, and therefore the range prediction on a series of questions of 15 like this would be a lot higher. The bars in the yellow were the students. Now, you can take a perspective here is that a lot of the performance in a quiz like this is likely due to just your normal experience in life and how you can perceive ranges. And so I kind of thought why this is skewed to the left is just because of the experience level of the students themselves. Okay. What's interesting, and you'll see this in the upcoming conclusion, is you can do this with any population, and it's nice to kind of understand in terms of the audience you're dealing with as part of a risk analysis, how calibrated they are. The second quiz dealt with true and false questions. And so here's an example. A statement like this would be given to them. Francis Scott Key wrote the lyrics, but not the music for the American national anthem is the statement. And so then they have to answer true or false and give some sort of confidence level. Okay, so you can provide an answer to say it's true, and then say, hey, I feel like I'm 90% confident. Now, obviously, if you don't have a clue and you're just guessing it's a 50-50 thing, you would actually put the confidence like the lower part of the scale, like 50 or 60%. If you truly know the answer, you would obviously either go 90 to 100%, given how confident you are. So it's an interesting kind of approach to the binary question here that's posed, okay? The next slide talks through the responses from the students on the true and false. And you can see because of the more orange, there were a lot more correct answers in the binary versus the range questions in quiz number 1, okay? And so the performance here was a lot better from the standpoint of against the questions that were there of being true or false. If you look at that performance and compare it against the normal distribution that we would see given a normal population of attendees, you can see that the students were pretty consistent with this. They're a little higher than the normal distribution because what you see is that the worst case scenario, 5 out of the 15 questions were answered by a number of students. Okay, so you kind of see consistency there. But what's most important about all this is not necessarily doing all these trivia questions, is to see what can you glean about the background of the audience. And so my audience here is a set of students. Okay, so in quiz number 1, you can assess their value of calibration. And there's a series of diagnostics you do on the number of questions answered correctly to find out who's calibrated, who's close to being calibrated, and who's not very well calibrated. And so you can see from the right 3 columns here, there's a lot of orange, meaning that the students were not well calibrated. That's consistent with the early distribution. The next 3 kind of columns look at the results from quiz number 2. Similar in terms of number of correct answers, you can do this analysis on how well people are calibrated. And you can see from a standpoint of the results in kind of the second colored column from the left, that we've got 4 students that were well calibrated, and a lot more are close to calibrated, and a lot less are not so well calibrated. Okay, the information that's provided when they guess their confidence level, there's a very clever perspective to see how confident they are where you compare the number of correct answers versus their confidence data they give for all the questions. And there's analysis you do. Basically, it's the number of correct answers minus the sum of their confidence entries. And once you kind of get an indicator from that calculation, you can assess to find out if someone is very well calibrated, someone's overconfident, and someone is underconfident. And what you can see here, we actually, under that test, we have a lot more calibrated, which are the green boxes. We actually had one student that was undercalibrated and still many that overcalibrated. The last diagnostic one can do here is the, I call it the 100% confidence batting average, meaning that if you were 100% confident in your answer and you were really well calibrated, you really understood it, you would get all those questions correct. And so we actually had a number of them that batted 1,000, meaning they got every question they said, they're 100% confident they had the right response, okay? And what's nice about this is the background is that you can use these diagnostics to try to figure out who's overconfident, who's well calibrated, maybe who's underconfident, and help you as a risk analyst to kind of steer the audience to get the most out of them. And that's really the output of this. So what are my key learnings from doing the calibration? Because this is the first time I actually did this with any audience at all. Basically, they're simple tests to help determine who can provide the most reasonable inputs into quantitative risk analysis models. And I would advocate this to be done as much as possible in future risk analysis. Once you identify that people are not well calibrated, that you can actually go through additional techniques to help elevate their ratings, okay? From a standpoint of the academic environment, is that the exercise of doing it was a nice change of pace. It was a quiz where they didn't have to worry about grades, was one way I put it. And so they did enjoy doing the quizzes and understanding the output from it. I plan to do this in future deliveries. One of the variations I'm planning to do is do the calibration as individuals and then calibration in teams of people, because I think it's interesting to see how the dynamics work with a group as opposed to individuals. I'm at my last slide for this particular presentation, and just to kind of wrap up with my overall key learnings and messages from this. The first one is, the statement is very clear. Hands-on use of NetPoint and NetRisk was very valuable to the students. And the trial versions of using the software was really perfect for the class. It was very interesting to see that one of the students in the class actually used NetPoint for their capstone project, which was another class. So they felt comfortable enough with using NetPoint as a scheduled presentation tool to go beyond the boundaries of my class, which is great to see. My case study topic was good, but I think it needs to be improved, okay? And so I'm gonna look to upgrade that. From a standpoint of the class, and you saw the student feedback and their overall rating, is that it's obviously working. The structure can be used in other academic environments as well as industry. I've done a lot of training both in academia as well as industry, and the kind of the approach I use with case studies works really well. Lastly, in terms introduction of the calibration testing revealed, not surprisingly, that students are not very well calibrated and are somewhat overconfident in what they know. However, what this brings in is what we're going to do for the next generation of the class is talk a little bit more about the cognitive biases that are underlying this. And I am probably working with other avenues within the university to kind of come in as guest speakers to help talk about cognitive biases. Okay. So that's the end of my assignment, and I will take any questions.
Hi, Jerry, we do have some questions. So the first question is, did the students' understanding of the base concepts match with your expectations?
Yes. Just to kind of qualify, I would say about 80% locked on immediately, and 20% took a little time to get there. It's kind of the 80-20 rule, but part of it is the approach that I tried to use in teaching, where it actually was a series of lectures that built in to be able to do both the use of NetPoint and NetRisk as well as doing the simulation.
All right, the next question is, What do you think about a longitudinal study to see whether this exposure had a long-term effect on the students of risk management in project management?
Well, that's a really good question. Part of the challenge is, getting feedback from students after they leave the university. And some are really good at staying connected with the university. Many are not. But it's a good question to consider from the standpoint of getting feedback. Just to kind of talk a little bit, a lot of the classes I like to bring in former students as well as colleagues that I've had within PMA as well as throughout industry to speak in the class and share their experiences. And so, perhaps over the years that if some of the students here actually get into risk management, bring them into this class.
Okay, the next question. How much would you charge, or how long does the class take for outsiders to take the class? It seems like you have a future pupil.
That's a good question. I haven't really thought through that. Certainly we could develop a course that, and I could deliver it through PMA as opposed to the University of Dayton. It depends. This course was, I'm trying to do the math in my head, something around 28 lectures. And so you just, that's going to be over a full week of time. And so that's what would be involved, but to put a number to that, I could certainly follow up with that. I don't want to give a number off the top of my head, but that would be, you can develop a full week course from this and whatever a full week course would cost.
All right, the next question. Would an online or on-demand version of this course work, in your opinion?
The answer is yes, because when we were in the middle of the pandemic, all my courses we had to do online for a period of time. Okay. Now, what we've learned is the absorption of the material isn't as strong in the online mode as opposed to being in class, but definitely it's something that can be done.
All right, the next question. Is there evidence for a strong correlation of calibration between different knowledge areas, general knowledge you used on the test versus construction or project specific information?
I think sometimes, well, I've not studied it. I'm certain that when one is familiar with the topics, it's easier to become more calibrated. What the calibration test is trying to do is think, how open-minded can you be? And when you don't really know something specifically, how could you go through the thinking process to come up with calibration areas? So having general knowledge questions as opposed to construction specific questions, I think is still a good indicator.
Okay, this may be our last question. I'll check to make sure there's no more after this. But is there anything else you would do differently for the exercise other than the base deterministic schedule?
Not really. I think the struggle was with defining what is the starting point they work from. The topic is good. What I ask the students to do is in line with doing any kind of schedule risk analysis. So it really is just, the kind of the base starting information is the thing that needs improvement.
All right, thank you so much.